Hello again. This time we're going to talk about perpendicular lines. So we've talked already about parallel lines. So we've talked about the fact that parallel lines have the same slope and they never meet. So they go up at the same rate, and wow, that is a genuinely terrible line, but you get my point. They go up at the same steepness, so the same gradient. They never meet. They're going to be parallel forever. Whereas perpendicular lines cross at perfect right angles. And again, I'm probably going to do a really rubbish version of this, but that would be what it would look like, and this would be a perfect right angle. So what that means is that the slope of one, so the slope of line number one, if it is A, then the slope of line 2 is negative 1 over A. So you flip it upside down and you turn it into a negative. So, or you turn it into a positive if it is a negative. You change the sign. So for here, if the slope is 2, the gradient is 2, then the new gradient would be negative 1/2. So you flip this upside down. Remember, you can think of any whole number as over 1. So this is 2 over 1. So we make it negative 1/2. If it's already negative, we're going to flip it upside down and we're going to change the sign. So we're going to make it positive 1/3. So for this one here, the next one, we're going to flip this upside down. We're going to make it negative 5. And for this one here, now this is going to stay a fraction because obviously there's no 1 involved, but we're just going to change the sign. So the second slope for this one, not the second slope, a perpendicular line would have a slope of positive 4/3, right? So the perpendicular line to these lines would have these slopes. So you flip it upside down, change the sign. So let's now try and apply that to coming up with full equations. All right, so if I said find a perpendicular line to this equation that passes through this point. So we already know how to do a bunch of these things. So, well, first of all, we don't even need to find the slope because we know the slope is negative 1/4. So that must mean the new slope is flip this upside down, so that makes it 4, and change the sign. So we're going to leave it as positive. So I know the slope, and remember this formula, y minus y1 equals mx minus x1. This is going to be your best friend, this formula. So we're going to use the new slope that we have and the point we've been given to substitute into this equation. So then I have y minus y1, which makes that plus 1, equals m, which is 4, x minus x1, which is negative 4, so that becomes plus 4. Now I'm just going to move my equation around. So y plus 1 equals, I'm going to distribute here, so 4x plus 16. Now I'm going to bring this across, so y equals 4x plus 15, because this comes across as a negative. So this is the equation that is perpendicular to this line and passes through this point. Now we could prove that with graphing, but we're not told to, so let's not waste our time drawing graphs when we don't need to. You just need to come up with the equation. So when you finish your equation, just double check that you ended up with the slope of 4, which we did, because if something goes wrong and you don't end up with that, well then you know you need to check your answers. And watch your signs as well. So these negatives had to turn into positives, because obviously minus a negative is a positive. Right. Now what if you get given slightly less information, but you still need to do this process? So over here, they're asking us to find a line that's perpendicular to a line that passes through these 2 points, and then it has to pass through this point. So the thing that we had before was that we already knew the slope of the original graph. Now we don't know that this time, so we have to find it out. So remember this lovely equation, y2 minus y1 over x2 minus x1. So we're going to use this equation first. Might just put some coloured bubbles around our fancy equations. So this is the equation. Oh, my pen's running out again. So we're going to use that equation and this one a lot. Yeah, I might need a new pink pen. All right, so the first thing I'm going to do is find the original slope. So I'm going to use these 2 points. So y2 minus y1 over x2 minus x1. All right, now this looks like it's not going to be very fun, is it? All right, so we have negative 6 minus 6, which is negative 12. 1 minus 3 is negative 2, so that gives us 6. All right, so what this means is if the slope of the original line is 6, my perpendicular slope of my next line is negative 1/6. All right, so we flip it, change the sign. Now, this is going to be messy because I'm going to have lots of terrible fractions, but that's okay. You're allowed to have fractions in your answer. We are not going to get nice whole number answers for this. So now I'm going to use this formula. So y minus y1, remember this is the point that we have to use now because this is the other line. This is the new line we're being told to use. So y minus y1 equals negative 1/6 because that's m, x minus x1, well, that becomes a plus 1 because it's negative. So then I'm going to distribute. So y minus 6 equals negative 1/6 minus 1/6. And then I have to add 6 over here. Whoops, I didn't put my x in, did I? So you can see we're going to end up with some nasty fractions. But again, that's okay. Negative 1/6 x minus 1/6. And I'm going to add, so 6, and I'm going to turn it into sixths, right? So 36 over 6 is 6. So I'm going to turn this into that. So y equals negative 1/6 x, and then I'm going to plus 35/6 because I just put those together. Now this is not a very fun looking answer, but it is correct, and we're allowed to have fractions. Please don't turn things into decimals because you'll end up having to round and use approximations, and we don't want to do that. Okay, so that's basically all you need to do. So these are our two formulas. You find the slope of the original line, then find your perpendicular slope, then use this formula to find your equation. All right, so let me know if you need some help. Otherwise, good luck.